So let's find the volume of the solid below the, whoops, this is kind of messed up. A little bit of a spelling issue there. Hyperboloid z equals 5 minus the square root of 1 plus x squared plus y squared, and above the following regions. Here's one region. We'll take a look at least one other. Okay, this is already set up in terms of a polar region, so I just want to convert this to polar coordinates. So I can rewrite z as being 5 minus the square root of 1 plus r squared, which is kind of nice because now if I integrate this is going to be a double integral over the region of 5 minus the square root of 1 plus r squared, r dr d theta. And this region, r would be going from 0 to 1, and theta from 0 to pi. And this is kind of nice now because I can set this up as a u substitution. And actually, I'm going to break this up a little bit more. It might be easier for you to see it. I'm going to break this up as two different integrals. The first one is from 0 to pi, 0 to 1 of 5r dr d theta minus integral 0 to pi, 0 to 1 of square root of 1 plus r squared times r dr d theta. So let's work with this integral first. This is going to be 5r squared over 2 from 0 to 1, which is just 5 halves. And then I've got the integral from 0 to pi of 5 halves d theta, which would be 5 halves theta from 0 to pi, which is 5 pi over 2. So this is the contribution for this first piece. And I need to subtract from it the contribution from the second piece. Well, let's go ahead and work with this inside piece here. So I'm going to have the integral from 0 to 1, square root of 1 plus r squared r dr. And I'm going to do a straight u substitution. Let u equal 1 plus r squared. Then du equals 2r dr, which means du over 2 equals r dr. The r dr is exactly what I have right there. So I will have the integral, well, 1/2 the integral of u to the 1/2 du, which is 1/2 times u to the 3/2 divided by 3/2, which is times 2/3. So the 2 is going to cancel. And this is going to be evaluated from 0 to 1. Whoops, I'm sorry. It's not evaluated from 0 to 1. I need to go back. I'm in u's right now. So this is going to actually give me, see, what do I have here? I have 1/3 1 times 1 plus r squared raised to the 3/2 all over, whoops, not over 3 because I just put the 3 there. The 3's right there. There we go. Now from 0 to 1, which gives me 1/3 times, this is 2 to the 3/2 minus, I'm sorry, 1/3 times 2 to the 3/2 minus, at 0, it's minus 1. So then I'm going to take and I'm going to integrate this. I'm going to have 1/3 times 2 to the 3/2 minus 1 d theta from 0 to pi, which is just going to be, see, 2 to the 3/2 minus 1 over 3 times theta. So I'm just going to multiply this whole thing by pi. And I need to take this piece and put it all together. So I will have 5 pi over 2 minus 2 to the 3/2 minus 1 over 3 pi, which I would probably pull out like a pi and say this is pi times 5/2 minus 2 to the 3/2 minus 1 over 3. Which, there's some stuff I could do to simplify this if I really wanted to. Obviously, 2 to the 3 halves, that's 2 root 2. So I could take this 5 halves minus, well, actually it could be a minus 1/3, so plus 1/3 minus 2 root 2 over 3. See, this could be a common denominator of 6. So this is going to be like 17 over 6 minus 2 root 2 over 3. And don't forget to bring back my pi. So these are the same thing. So it just kind of depends on what mood you happen to be in at the time.